Now we have a better understanding of some of the different renewable energy technologies that are available to us, as well as some of the different energy storage technologies. We are now in a better position to evaluate those different technologies. So in this video tutorial, we're going to look at how we can classify renewable energy sources based on whether they produce energy in an intermittent fashion or continuously. We'll also recap the different energy storage technologies that are available and how they can be used alongside our intermittent and continuous energy generation technologies. We'll then look at the benefits of combining different renewable energy sources and storage technologies, and we'll assess this in the context of both large-scale generation and small-scale generation projects. Finally, I'm going to encourage you to think about the use of renewables in a local and domestic context. So to begin with then, we've seen lots of different renewable energy technologies, but when we evaluate these technologies, it's important to understand how to classify each of those technologies. Now we have some technologies that are intermittent or weather dependent. Now the obvious example there is wind farms. We have both onshore and offshore wind farms, but we can't guarantee that the wind is always going to be blowing. Offshore wind is a lot more consistent than onshore wind, but it's still an intermittent energy source. Another example of an intermittent energy source is solar farms, and we've seen both solar PV or photovoltaic as well as solar thermal plants. Now both of those technologies are going to be intermittent because we have solar energy available in the daytime and we don't have solar energy available at night time. We also don't necessarily have solar energy available in sufficient quantities if the weather's cloudy or overcast. So those technologies would be considered as intermittent or weather dependent. The next classifications that we have would be predictable, continuous and on-demand technologies. So the first one that I have there is ocean and tidal energy. Now we can't really classify this energy source as continuous, because particularly in oceans, the tide goes out at a particular time of day and comes in at a particular time of day. So whilst they're not technically continuous energy sources, they are predictable because we know when the tides are going to change. So ocean and tidal would be classified as predictable technologies. Continuous technologies are things such as geothermal. Now the geothermal reserve in the Earth's crust is always available. Providing we're in a location where that can be accessed and there's a reasonable geothermal reserve, we can generate continuous energy from that energy source. And these types of energy sources are ideal for providing a baseline of energy. We then have on-demand energy sources. And on-demand energy sources are energy sources that can be switched on and switched off in order to meet fluctuations on the grid. So examples of on-demand energy sources are things such as biomass and waste to energy. Now, alongside on-demand energy sources, we also need to consider energy storage. So we've seen how solar thermal energy can be stored in molten salts, and that can be stored for use when there's fluctuations on the grid. Although what we're really storing there is thermal energy. Other examples we've seen are pumped hydroelectric storage and hydrogen storage technologies. And in each of these two, we're storing potential energy. In the pumped hydroelectric storage plant, we're storing gravitational potential energy. And in hydrogen storage, we're storing chemical potential energy. The other energy storage technology we've seen is battery storage. And we talked about how battery storage could apply on a large scale, but also to smaller or micro generation projects. Now, the important thing with each of these energy storage technologies is that they can also be used to provide on-demand electricity, providing we have sufficient storage. If there's any fluctuations on the grid, as an example, we can release the energy from any of these storage technologies in order to meet those fluctuations in demand. And as we'll see in a moment, it's really important that we have the capacity to do that. So what are some of the benefits of combining renewable energy sources and storage technologies, rather than relying on individual renewable energy sources in isolation? Well, if we think of this first of all in the context of large-scale generation, one of the benefits of having solar farms, wind farms, geothermal power plants, And biomass power plants, as an example, is that we can maximise the use of green energy sources. So some of these can be producing energy when others are not available, and vice versa. It means we have a greater reserve or a greater potential for utilising green energy sources. Now, we also saw that each of those renewable energy technologies have their own benefits or their own advantages. So with the likes of the geothermal energy, we can use something like geothermal energy to provide a baseline of energy or a constant steady amount of energy. And geothermal plant, as an example, can provide energy throughout the day and throughout the night, and it's also not weather dependent. The other benefits of some of those on-demand technologies is that they can be switched on and switched off as and when required. Now, as you can imagine, there are fluctuations in energy requirements at different times of the day. So in the winter, at night time, people are going to have their lights on, which is going to consume electricity. During working hours, when offices and businesses are open, we're also going to be consuming more electricity as those businesses carry out their day-to-day business. And as you can imagine, during the night time, less electricity is being consumed as people sleep. We might also see differences in energy uses from Monday to Friday when compared to Saturday and Sunday. So it's important to be able to switch on and off various different energy sources in order to meet changes in demand. The other type of fluctuation we might see is seasonal fluctuation. In the summer, we have a lot more daylight, so we're not using things such as artificial lighting. Whereas in the winter, the days are much shorter and we are more reliant on artificial lighting. In other countries, in the summer, there is a requirement for air conditioning. So there's lots of different factors affecting the energy demand at any one time. We also talked about the importance of being able to store surplus energy. Now, once again, that's useful because we can meet energy demand, but it also means we're not wasting energy. If we're able to store renewable energy, then we're less likely to need to rely on the burning of gas or non-renewable energy sources. So it's important to combine lots of different renewable energy sources to reduce reliance on any individual one renewable energy source, but also to reduce our reliance on fossil fuels and energy imported from other countries. Now, we should also consider the benefits of combining renewable energy sources and storage for small-scale generation projects. And by small scale, we're referring to homes and businesses. Now, for a domestic premises, generating electricity from solar panels as an example, they're actually able to reduce their own energy bills. In addition, any surplus that's fed back into the grid can potentially generate revenue for that property. Another important consideration or benefit is reducing exposure to the volatile energy prices or the volatile energy market. If you're generating your own electricity, then the proportion of electricity that you're purchasing from the energy suppliers is going to be reduced. And we've seen how volatile the energy market can be over recent years. So any measures we can take to reduce our exposure to the volatile energy market is going to be advantageous. Now, another benefit then is for security of electricity supply. For a home or business generating their own electricity, they're less reliant on electricity from the grid. Unfortunately, there's always the potential for outages on the grid, and so for homes and businesses generating their own electricity, they can secure their own electricity supply. Now, it's important to remember that even homes and businesses can benefit from energy storage technologies. Many of the solar panel installations currently taking place will also include battery storage. So any home or business installing solar panels is most likely going to have the option to include battery storage, which once again is going to provide them with security of energy supply. If businesses are making use of solar panels or wind turbines, then they may also consider installing battery storage. The other benefit then of combining different renewable energy sources is that we'll be contributing to reducing greenhouse gas emissions. Now, we know that our UK government has a commitment to be net zero by the year 2050, and in order to achieve net zero targets, one of the main goals is to decarbonise the power sector, so remove the use of fossil fuels for all electricity generation. We also know that there's a shift away from petrol and diesel vehicles. So as we see more households using electric vehicles, we're going to see an increased demand for solar panels and battery storage within those households. So the other thing that I want you to think about is how renewable energy sources are being used in your local area. If we consider the UK in general, there are numerous offshore wind farms in the North Sea or to the east coast of the United Kingdom. But we're also seeing a lot more onshore wind farms, particularly in the north of England. One of the reasons wind farms are so popular in the UK is because we tend to be a very windy island due to our geographical location. As we've seen throughout this video, one of the drawbacks of using wind turbines is that we have an increased need for things such as battery storage to ensure that we're not wasting electricity generated when demand is low. The other trend that we're seeing throughout the UK is the installation of solar panels on domestic premises. The reason why solar panels are more popular for homes and businesses rather than wind turbines is because they don't require any additional land. Solar panels installed on the roof of a home don't take up any additional space, and so they're an ideal solution for homes looking to generate their own renewable electricity. Ideally, that would be combined with battery storage to enable that premises to become self-sufficient in terms of energy production and energy demand. Now, if we think wider afield, in other areas of the UK, such as in the southwest, we're seeing the development of geothermal power plants, and the reason for that is because there is a good geothermal reserve in the southwest of England. So depending on your location, you may see renewable energy being used in different ways. If we think more broadly, we're also seeing many of our old coal-burning power plants being converted to biomass power plants. So there's been a noticeable increase in the adoption of renewable energy sources, which is something we would expect to continue. So just to summarise then, in this video we've looked at how we can classify renewable energy sources based on whether they're intermittent or weather dependent, predictable, continuous or on demand, and we've also considered the benefits of different energy storage technologies. We've discussed the advantages of combining different renewable energy sources and storage rather than relying on single sources in isolation, and we considered that in the context of both large-scale and small-scale generation projects. Finally, we've discussed how renewable energy is being used in different areas around the UK, both for large-scale projects such as geothermal power plant and biomass power plant, as well as small-scale generation such as solar panels, particularly on the rooftops of domestic premises. So I hope you found this video useful, and thanks for listening.